and a very good morning to our chief guest, Soumili Pal. So let me give a short introduction. She is our ex-student. You have come to know about that, and she was a very well-behaved one, and she scored, in her chemistry, she scored 100. So she passed out in the year 2018. A very warm welcome to Soumili Pal. We are very happy to have her here with us today. So she will be sharing some of her learning experiences, and she will speak on the future prospects in chemistry. So I hope after attending the session, you will be definitely gaining something. And if you have any questions, please feel free to ask her. So let's begin the session. And a short introduction that will be shown on the slides. Just have patience and attend the program. Thank you.
So good morning to my respected teachers and my fellow juniors. I am Soumili Pal. And as you can see, I passed out from the Future Foundation School in 2018. And I wouldn't be standing here without them. Like, I am very, very grateful to all the teachers of the Future Foundation School. And it's very nostalgic when I remember, like, I used to sit on that side of the stage and used to listen to the seminars and the projects that were conducted at that time. And today I am standing on this side of the stage. So I would like to thank DC ma'am, who taught us organic chemistry, Shongita ma'am, who taught us inorganic part, and Piali ma'am, who taught us how to use the lab apparatus and the lab instruments. And a special mention to Kakuli ma'am, who taught us biology. Like, the biology syllabus is very huge, as you all know. And we used to often used to ask ma'am, we have to study this, ma'am, this is very tough. And ma'am used to like answer the topic, explain the topic in very simple words so that we can grasp quickly. So I am very grateful to the Future Foundation School for grooming us so nicely. They not only taught us how to flourish in our academics, but also how to be good human beings, which is a very important part of our life. So I start here. I want this session to be interactive also, because with 1 to 1.5 hours, you all will get bored with all the information and all. So I passed from the Future Foundation School in 2018 with 96.5% and 100 out of 100 in chemistry. So this is the school where it all started, and I saw my passion. Can I go to the next slide? Okay. So I followed my passion. From class 11 only, I had the feeling that I had something special for chemistry. And so I didn't go into engineering or doctor degrees, as we all know that they are the rat race in our generation now. So I went with my passion, and I completed my BSc in chemistry honors from Jadavpur University with 8.86 CGPA. And I was awarded a gold medal for being the topper of my batch. And in the same year only, I cracked the joint admission test for masters, which is the IIT JAM. I will talk about it later, with all India rank of 264, and I got admission into IIT Guwahati. And last month only, in May 2023, I completed my 2 years course, masters in chemistry, with 9.60 CPI. And in August, like in the next month, only 19 days are left, I will be moving to the US for pursuing my PhD in chemistry at the University of Florida. So as we know that there are various branches of chemistry, and one can pursue one's major in any of these branches. Like me, myself, is an organic chemistry major. So there are various branches of chemistry, as you can see: physical chemistry, inorganic, organic, computational, biochemistry, analytical. And the most important thing that I would like to say is that all these branches are interrelated. Like, if you want to do your major in biochemistry, you can't forget inorganic or organic chemistry. Like, if you love inorganic chemistry, you can't forget organic, physical, or analytical chemistry. That's not possible. You have to have a grasp on every branch of chemistry with a deep and better understanding in your branch of chemistry. So nowadays, physical chemistry has been a part of material science. So what is material science? What do material chemists do? Like, they explore and research new materials, like they discover new materials. They characterize the properties of different substances, like their superconductivity, their porosity, their hydrophobicity, etc. And as we know that nanotechnology is an emerging branch of science now. Like, is an emerging, many of my batchmates from IIT Guwahati has pursued or will be pursuing their PhD journey in nanotechnology only. Like nanotechnology is the branch of chemistry which manipulates the size of matter to nanoscale to discover new materials, new devices, etc. And we can do a lot of things with that. So it's a very emerging branch of science. So if any of you are is interested in nanotechnology, you can pursue nanotechnology as your like MSc thesis or PhD or anything. And as I said earlier that none of the branch of chemistry can be isolated. Like you can't only study inorganic chemistry and forget all the branches of chemistry. Like me myself is an organic chemistry major, but I know inorganic chemistry, physical chemistry, and analytics. If I didn't know all of them, then I wouldn't be pursuing PhD in the US. So we see that inorganic chemistry is integrated with other branches of chemistry like physical chemistry, analytical chemistry, inorganic chemistry, etc. like that. And if you discover a certain material, like a certain new compound you have discovered in the lab, and you want to publish it in your journal, if you don't know the analytical methods, like you don't know how to characterize the new compound, it's of no use. You have to know the spectroscopic method. You have to know NMR spectroscopy. You have to know mass spectroscopy to know the structure of the compound. Like you can't write in a journal like I discovered this material. No, you have to give the structure, you have to give the name. So without knowing the analytical methods, it's not possible for anyone to pursue inorganic chemistry or any branch of chemistry. So inorganic chemistry includes a vast terrain of science. Coordination chemistry, it's a very, very important topic, I would say, and it helped me personally in a very long run. Like in a 10+2 level, we have coordination chemistry as a subject, as a topic only. So in coordination chemistry, we know it involves various metal ions and ligands that are useful in our everyday life or maintain biological processes in living beings. And we get to know the roles and the functions of the ligands and the metal ions. Like if we change the metal or the ligands around them, the role, the function of that metal complex totally changes, as you all know. Now metallurgy is very common, like it's the extraction of metals from ores and the separation by various techniques. You all know better than me. And the next two terms, like the covalent organic frameworks and the metal organic framework, these two terms might seem a little out of the box, but I will explain. So covalent organic frameworks, abbreviated as COFs, and metal organic frameworks, abbreviated as MOFs. These two are like mostly similar. They're like coordination polymers where they have potential voids, but in the MOFs, they have a metal inside them, and in COFs, there is no metal. So what's the use of the two things? Like COFs is mainly used in the biomedical processes, like in the drug delivery system or the anti-cancer agents, like this. And these metal organic frameworks, they have a huge surface area and volume. So they're used for absorbing liquids and gases. And bioinorganic is a very, very important stream of inorganic, I would say. Like it helps us to study the biological processes that are going in the living organisms. And I will tell earlier that biochemistry is also an important branch of chemistry, and it involves bioorganic, bioinorganic both. So bioinorganic is a very interesting, I would say, and a very creative branch of science. And it involves inorganic compounds, metal ions, coordination complexes, everything. So if you want to pursue bioinorganic chemistry, you can't forget coordination chemistry. That's not possible. So everything is interlinked. So like I am an organic chemistry major, I don't know anything about inorganic, I don't know anything about NMR spectroscopy, that's not possible. So now comes organic chemistry. I am a little bit partial towards organic chemistry because myself is an organic chemistry major, as I told earlier. So organic chemistry is highly creative. It's highly creative. Like if you love organic chemistry, achieving great heights become easy. I would like to say this. And many of my batchmates who are interested more in material science, they ask me how are you so interested in organic? How do you remember so many reactions and so many reagents? Like how it's possible? In my school life also, many of my friends asked me this. In my bachelor's, in my master's, many of my friends asked me this. So I would like to say there are many reactions, there are many reagents, it's there. But if you know the mechanism behind a particular reaction, you can apply it to various other reactions. You have to know the mechanism. By like mugging up the reaction, it's not possible. There are 2,000, 3,000. I also don't know all the name reactions. If you ask me a name reaction, I also can't remember all. It's not possible. But if you know the mechanism behind, you can apply it. If you know the reagent, the application of a reagent, you can like apply that application to other reactions. So as we know that organic compounds are all around us, and more or less everything around us is made of organic compounds, and organic chemistry is the foundation of all, I would like to say. I will discuss my MSc thesis, which I did on synthetic organic chemistry in the later slides, but let's move on, because if I start talking about organic chemistry, the 1.5 hours will be gone. So now, it's a very important branch of science, that is computational chemistry. I didn't know much about computational chemistry till I got into my master's, because computational chemistry is not a very like high branch of science which is taught in our bachelor's. The computational chemistry is that branch of chemistry which involves programs to solve the chemical problems. It's like a theoretical chemistry that you don't have to go to the lab. It's a benefit of computational chemistry. You have to just sit in front of a laptop with your programming software, and you can solve all the chemical problems. It's basically theoretical chemistry, and it helps as various softwares to calculate the properties of different materials. Like a computational chemist can identify sites on a protein molecule like that are feasible for the attack of a new drug molecule. Or a computational chemist can monitor the thermodynamics and the kinetics of a reaction. Or as I said, that you can characterize the different properties like the superconductivity, the energy storage, or the porosity, the hydrophobicity, etc. So it's a very emerging branch of science, and if you don't want to go to lab and you don't want to have hands-on experience and you are good with programming languages, computational chemistry is your choice, I would like to say. Oh, now comes biochemistry. Biochemistry is a very, very like important branch of science where you have to know both biology and chemistry. Biochemistry helps us to study the biological processes that are going in us or any other living organisms. And we can solve a lot of like various problems that we face every day with the help of biochemistry. And biochemistry has played an important, very important role in the discovery of anti-cancer drugs. Like anti-cancer drugs work in us by various methods, like DNA intercalation methods, DNA coordination method. And these principles can only be studied by biochemistry and nothing else. Like we know that cisplatin, you all have heard, I guess, that cisplatin is a very reliable drug for as an anti-cancer agent. But nowadays, ruthenium-based drugs has also been found for being the anti-cancer drugs. This all I got to know in my master's only. Like in bachelor's, there were so many topics. Like there are 6 semesters in our bachelor 3 years course. There were so many topics that going depth into one topic, it was not possible. But in masters, when you get to, like, there are 4 semesters, but the topics are like very, very important. They're in depth, like anti-cancer agent. The topic is, and on that topic, like 3 to 4 weeks, 10 to 20 lectures are being taught. So you get to know a lot of things. So as I told, the ruthenium-based drugs has also is a reliable thing now, and which drug is more reliable, which has the less side effects, which is more effective in our body. All these things are studied by biochemistry only. So for biochemistry, you have to know both biology and chemistry. Now, chemical biology. It may seem that biochemistry and chemical biology, both of them are like the same things. But biochemistry is the study of biological processes in us or in other living beings. Chemical biology is the study and the manipulation of that biological processes that happen in us by applying various techniques, chemical methods. Like as we know that there are biological processes going in us, and we all know that biological processes are like chemical reactions, normal chemical reactions, and all of them are regulated by the enzymes. And these enzymes are also like chemicals, they are only chemicals. So if we change a enzyme or change a functional group or a ligand or a metal ion in an enzyme, their role, their function, everything changes. Their binding capacity, everything changes. So all these manipulations, these are taught under this chemical biology. And DNA, RNA, all these things you know better than me. Translation, transcription. Peptide synthesis is like the formation of compounds where amino acids are linked by the peptide bonds. And genetic engineering is like changing the genetic makeup of a living organism, like if someone is having a disease. So by changing that DNA or that part of the DNA, we can like cure that disease, like a single nucleotide polymorphism, SNPs, you will learn in your higher studies if you pursue chemistry or biology. In biology it's also taught. So these all things are taught under chemical biology. Now, here comes the very, very important topic, analytical chemistry. Now, analytical chemistry is like the analysis of compounds, like what are the elements present in that compound. Like if I bring soil from moon, what are the elements present in that soil? All these are studied by analytical chemistry. Now, the instrumental methods in the analytical chemistry are the very, very, very important things, like NMR spectroscopy, nuclear magnetic resonance. Now, what is nuclear magnetic resonance? I will give a brief description. Like we use radio waves in this spectroscopy. In NMR machine, we put our sample dissolved in any solvent like CDCl3, acetone, anything, and by a software, like I use Mestrinova software, by a software we get the peaks. We get some peaks, and within what range that peaks is coming, the peaks are coming, we get to know that what functional groups are present, like how many hydrogens are present, how many carbons are present, is there a double bond, is there a single bond. All these are studied by NMR spectroscopy. Like I said earlier, if you discover a new compound, like let it be inorganic, organic, any compound, if you have to know the structure of the compound, you have to know NMR spectroscopy. Like NMR spectroscopy is very, very important. And mass spectroscopy is important, but NMR is more like reliable one. By mass spectroscopy, we get the molecular weight of the compound. Like if the molecular compound has lost 18 molecular mass, we will say that it has lost a water molecule. Like this only. We get to study the structure and what is the chemical reaction that the particular compound is undergoing by this mass spectroscopy. And thermogravimetric analysis is the, like you can say that monitor a compound's thermal stability. Like, and the fraction of volatile compounds that are present in it by monitoring the change in weight of that particular compound. And chromatography. Chromatography is very, very important, I would say. Chromatography is used to monitor the pace of a reaction, like how far my reaction has proceeded. That is monitored by chromatography. Like I am taking a reagent A and a reagent B, and I am producing a new compound or a new product, like you can say C. And after 8 hours of my reaction, I am seeing that my starting material A is like 80% done, like it's vanished 80%, and my starting material B is still left, like 80% of my starting material is left. And I am getting a new product C, which is like 50 to 60% formed. Like we can tell this by the intensity of the spots that are formed. And if it is like if the product is formed above the starting materials, we will say that the product formed is non-polar compared to my starting materials. And if it is formed below my starting materials, I will say that it's polar compared to my starting materials. So I saw that the conversion is not very good. Let's continue the reaction for another 8 hours. Then again after 8 hours, I saw that no, my compound A is almost vanished, my compound B is almost vanished, and my product C has all formed like 100%. And there is never 100% conversion, never ever. We can't say that this product gave us 99% yield, never. I cannot write in a journal that no, my product is 100% yield. I can't write, because some amount of product or starting material is lost while doing the reaction or in solvent or anything. So I come to the second part of my lecture, that is synthetic organic chemistry. Now I'm shifting to my pace, to my interest. Synthetic organic chemistry is the art and the science of constructing new organic molecules, as we can say. And in my MSc thesis, I worked on catalytic asymmetric dearomatization. So these terms may look like haunt you, but these are easy things. So I worked under Dr. Subhash Chandra Pan, and he can stand here. Like, he gave me everything, his recommendations, which are the best universities, his connections, and everything. So, as you know, what is dearomatization? Like, aromaticity we know is the driving process of every reaction. Like, it is a very favorable process. In class 12 only we studied aromaticity is a driving force of many reactions. But why I am so focused on dearomatizing a compound, which is an unfavorable process? So I would like to say the importance of dearomatization in the next slide. But I would like to say that dearomatization can be of two types: intermolecular dearomatization and intramolecular dearomatization. Intermolecular dearomatization is as we know, that we take two aromatic compounds, and under some reaction conditions or by employing some reagent, we form a product or products where there is no aromaticity. The complete aromaticity has been lost. And by intramolecular dearomatization, by the word intra, we know that we are taking only one aromatic compound, and under various reaction conditions or by employing a reagent, it is undergoing some sort of reactions, and it is forming a product where there is no aromaticity. So as I told earlier, that why I am so interested in dearomatizing a subject like a compound which is a very highly unfavorable process. It against the energy, like I would say. So one of the most challenging tasks for organic chemists is to produce a quaternary center, like a chiral center, where there are four different groups, and this can be done by the dearomatization protocol. And why I am so keen in forming a quaternary center? What is the use? These are the structural motifs or the precursors that are found in the biologically active natural products or in the therapeutic reagents. So my research work has a medicinal applications. So dearomatization reactions are no longer the restrictive area for organic synthesis, and compounds containing chiral quaternary carbon center are an important class of compounds which are found in the biologically active natural products or in the therapeutic reagents. Like, I have given an example. You can see hepatitis C virus polymerase inhibitor, and there is a chiral center where there is one N and three sides are different. You can see. So this can only be formed by the dearomatization technique. So this is what I did. I am saying everything very shortly, like my master's thesis was 55 pages. So I am shortening everything in 4 to 5 slides, because all these things will go a little up above your head. So what I did was a synthesis of 2,1-hydroxy naphthalene 2-yle methyl benzaldehyde. That is the structure of the compound. This was the starting material only. Okay. So this is the structure of the compound that I formed. So what was the reaction scheme that I used to form this compound? I first took alpha tetralone and orthobromobenzaldehyde. And under reaction conditions like potassium tert-butoxide and butanol, it took under refluxing conditions for 16 hours. In my MSc thesis I wrote 16 hours, but I kept it overnight only. So it's a 100°C reaction, and what we got is S1 with 75% yield. So I will describe the mechanism in the next slide, but let's see the reaction scheme first. And what I did, I protected the OH group. Like, I used tertiary butyl dimethylsilyl chloride to convert OH to OTBS, and imidazole has been used as a base, as you all know, and DCM was a solvent there, to get S2. And after S2, what I did, I used N-butyl lithium. I lithiated the compound first. Like I converted CBr to CLI bond first, and then I formylated that agent by using the formylating agent dimethylformamide. And it's a very, very important step because it took place at minus 78 degrees Celsius. Minus 78, like there are machines in our organic chemistry labs where we used to maintain the temperature of minus 78 degrees Celsius by using methanol. We can't use water there because water will freeze, we know. So we used methanol. And then my S3, S2 to S3, this is the key step in our reaction. And after S3, what we did, at the first we protected OH to OTBS. Now we are deprotecting it. Like we are again converting OTBS to OH. What we used was tetrabutyl ammonium fluoride in THF solvent, and this was a room temperature reaction, 10 minutes reaction. To get 1A, and 1A is our starting material. This is the starting material. Our key step will be there is no step of dearomatization, as you can see. My MSc thesis was on dearomatization. No step of dearomatization is present here. So 1A was the starting material. So after so many steps, I only got my starting material. So here comes the mechanism. So we are all familiar with aldol condensation, I think. Okay. So first, alpha tetralone underwent aldol-kind reaction, I would say, by using potassium tert-butoxide to form an enolate, and it attacked the aldehyde group of orthobromobenzaldehyde to form the intermediate, as you can see in that bracket. And as I told earlier, that the heating conditions was 100 degrees Celsius, and under 100 degrees Celsius, we found that it got aromatized. And how we found that? By NMR spectroscopy. So for every step, for every compound, for every product, I took NMR spectroscopy and saw that this is my product. If my first step is not done, then I can't proceed. So I have to confirm in every step, no, this is my product. Now I can go to the next step. And in the next step, as you can see, that the lone pair of OH attacked silicon, and Cl was the leaving group, imidazole as the reagent, as the base. So it's OH or O minus, like if imidazole is abstracting proton, then it's O minus or OH, as you can see. And it's forming that OTBS, OH converted to OTBS. And in step 3, we lithiated the compound first. For the first 5 hours, we lithiated it. So we lithiated the compound first, like with N-butyl lithium, we converted CBr to CLI. And then we did the formylation of the reaction, like this. CLI is what? Like C minus and Li plus. And this C minus is now attacking the aldehyde group of DMF, dimethylformamide, to get the formylating agent, as we can see in step 3. So CBr converted to CHO. Now in the last step, what we did was the deprotection, converting OTBS again to OH. So for this, I used TBAF. What is TBAF? It's tetrabutyl ammonium fluoride. Silicon and fluorine, they have a very special bond. Like whenever fluoride ion sees silicon, it attacks it. So I use that application, and as you can see, that TBAF, that fluoride, attack that silicon, and we get our deprotected starting material. This is only my starting material. And there are many steps. Can we go to the the previous slide? There are many there are many things I did, but I didn't show. Like I explored the substrate scope of this reaction. Like this is only alpha tetralone. This is without any substitution. I took 2 chloro, 3 bromo, 5 fluoro. Like this, I formed 80 compounds. 80 compounds, and taking NMR of every particular product. So I explored the substrate code, but I didn't show here because it will be very hectic for you all. So okay, ma'am. Thank you. So this is the key step, that is a dearomatization step. So 1A was our starting material, as I told. And what we used nitromethane and ammonium acetate at 100 degrees Celsius to form my dearomatized product. That is the 2A. I will show the mechanism in the next slide. So how did I know that it's going to work with ammonium acetate and nothing else? How did I make sure that this is going to give me the highest yield? I did the optimization technique. Optimization techniques is optimization techniques are when you optimize the reaction. You change the catalyst, you change the temperature, you change the solvent, and see where your yield is the highest. At first I used no catalyst and there was no yield, you can see. Then DBU and DIP are bulky, they are bulky bases, and there was no yield. ET3A, sodium acetate, sodium carbonate, sodium iodide, there was a trace yield, and with ammonium acetate I got 20% yield, then 41%, then 17. What is HC, 9D and 10E? HC was performed at 50 degrees Celsius, 9D was performed at 75 degrees Celsius, and 10E was found at 100 degrees Celsius, and my reaction is at 100 degrees Celsius. So how did I know that ammonium acetate? So I optimized the reaction. I used various other reagents to know that my ammonium acetate is only giving me the highest yield. So how did I maintain the temperature? HC, as I told, it's 50 degree, then 75 degree, then 100 degree. Why I only increased the temperature and not decreased it? At 50 degrees Celsius, I saw my yield is coming 20%. So I may increase the temperature or decrease the temperature and see at which temperature my yield is the best. At first, I decreased the temperature and I saw that my yield is decreasing. So if I further decrease, it's going to vanish, no product will come. So then I started increasing my temperature, and at 75 degrees Celsius, I found that it's increasing. The yield is increasing. It increased to 41%, and at 100 degrees Celsius, it increased to 78%. So optimization is a very, very important step in all the chemical reactions. You are changing the solvent. You are doing, here there is no role of solvent such. Nitromethane is itself a liquid. It's acting as a solvent and a reagent both here. Okay, so if you are changing the solvent, in CH2Cl2, my yield is coming less. So I change the solvent to acetone. So I change the solvent to some other reagent, other solvent. So these are the optimization techniques. So I did my optimization on ammonium acetate on the base, and I varied the time also, and on the temperature also. So here comes the mechanism of the dearomatization technique only. So what I took, 1A is my starting material, as I told, and now then I used nitromethane. So nitromethane is first getting deprotonated. CH3NO2 is getting converted to CH2 minus NO2. Okay, and now it's attacking that aldehyde group of 1A, and it's again you can say an aldol reaction, but it's a Henry reaction, we say. You will in class 2 level, I think Henry reaction is there. I don't remember, but it's a Henry reaction. CH2 minus NO2 is attacking this CHO, and it's forming this I1 is our first intermediate, and then it's undergoing dehydration minus H2O to form I2, and then it is undergoing an intramolecular dearomatization technique to form 2A. See, there is no aromatization in this ring. It was first aromatized, the second ring. Now it's not aromatized. So the aromaticity has been lost. And as you can see, I formed a center, this center, which is a quaternary center. So these are the structural motifs or the precursor of the various compounds found in the therapeutic reagents on the biologically active natural products, as I said. So I completed my MSc thesis in 4 to 5 slides. This is a big achievement for me. So, and I did the last step, like I explained earlier, that I formed 80 compounds. I explored the substrate scope. I did the last step also for all the all the compounds. Last step is the key step, and after that I submitted 30 to 40 only NMR data to say that no, this is mine. Our professors, the professors will cross you a lot. If you don't give an NMR of a particular a particular step, they will ask, how did you know that this is a product? Like I have to show something. No, this is the product I got. So here I come to the third and the last part of my presentation, like the future aspects of chemistry, like what you can all do after if you love chemistry. What I did after when I found that no, I love chemistry. So after ISc, Bachelor's of Science in Chemistry Honours, you can do it from various universities of India. There are various universities. In my time, it was a 3 years course, but I'm hearing that it's going to be a 4 years course now. I don't think there is any official notice, but there is a saying. So you may see that. And there are various institutions which provide us a BSMS course. Like I did my bachelor's for 3 years and did my master's for 2 years. So total, it was a 5 years course. But BSMS course is a 4 years course. Like you will complete your bachelor's and master's both in 4 years. And all this BSMS course can be done from the various ISERs. ISC, NATS. There are 3 topics. First 10 questions of MCQs are 1 mark each, 0.33 negative marking. Second 10 are 2 marks each, 0.66 negative marking. And MSQs, I don't remember how many are there, but 2 marks and 0.66 negative marking. And in NAT, there is no negative marking, like you can write anything. And this JAM gave me very, very important scope to do my master's in IIT. But I also want to say that if I didn't have done my master's in IIT, I wouldn't be going to US. Like IIT gave me everything. Like the scope from the very first day, they taught us a lot of the scopes after MSc. You should do PhD. You are researchers of this world. You are the future. Like you are the future. If you are the researchers, you are the future. And from IIT, from JAM, you can go into IISc Bangalore, NITs and IITs. Like for NITs and IITs, there is no no screening test after that exam. Like there is no interview. But for IISc Bangalore, if you have a very good rank, you will fill the form of IISc Bangalore, and you have to sit for an interview. Like the final decision of IISc Bangalore only is based on that interview. And but in IITs and NITs, there is nothing like that. But I would like to say the seats for IITs in chemistry is very, very less. For general students, up to 550 rank. After 550, there is nothing for general students in the IITs. And for NITs, it goes up to like 950 something. So ISERs also take students based on their JAM ranks. Like after JAM, you will fill the form, like I'm interested in this ISER, and based on your rank, they will shortlist you, and they will schedule your interview. So the final decisions are made on that interview. So I was also admitted to ISER Pune. So I filled the ISER Pune form, and I still remember after the interview, my name was at the first of the merit list. Like I was the top one. So my mother was like, no, you got this top one, you should go to ISER Pune. But I didn't go because it's an integrated MSc PhD course. Like I have to be there for 6 years. And I could not go out after MSc like I'm going now. So I got into IIT, and we know that we all have a brand name, IIT. So, and some ISERs, like if you don't have a good rank also in IIT JAM, you can go to ISERs like ISER Bhopal. Takes a different test. On admission test is taken, like a written test, and then an interview. Like they shortlist on basis of JAM ranks, and this test is also taken. So you have a scope if you do not have a good rank in your JAM. And there are other university exams also, like Common University Entrance Test and Delhi University. You know that Delhi University is very good. And JNCSR Bangalore. So JNCSR Bangalore also takes students for the MSc and the integrated MSc PhD course. I was also admitted to JNCSR Bangalore, but I didn't go. So JNCSR Bangalore is a very, very good institution, like very good. Like the integrated course is much, much better than the MSc course. Okay, so JNCSR Bangalore is a very good option. and TIFR Mumbai and TIFR Hyderabad. So they take a separate test, and after passing that test, interview is taken and they admit students. Like one of my friends from Future Foundation School only, Shulogna, he is doing her integrated MSc PhD in physics from TIFR Mumbai. So TIFR is a very good option. So after completing your MSc in chemistry, what are the options? I want to say that BSc CGPA matters. Above 8.5 it's good, above 9 it's very good. But the MSc CPI matters a lot. A lot, I would like to say. Like in various institutions, they say, like in the US universities only, they say that above 8 CGPA we will take students, but that's only written in the portal. They don't take. I myself know one of my batchmate, he had 8.86 CGPA. He got into a university, but I won't take the name of the university, but he got 9 rejections and 1 acceptance only out of 10. Okay, so CPI matters a lot. You go into IIT and you know, I got into IIT and now no. You have to study. Study and hard work, it's everything. So I want to proceed, like if you want to pursue your PhD in chemistry, by then you will know your specification, like you are inorganic or organic or physical, from India or from abroad. And you can go into corporate jobs also. Like if you are no more interested in, no, I don't want to do my PhD or research for 5 years, you can go into corporate jobs. Like IIT placement cells give chemistry trainee faculty in various institutions like Allen, FITZI, Akash. 20 of my batchmates got into Akash this year. 20 of my batchmates, and they are now training in Navi Mumbai. Okay, so and you can, if you want to, like I want to have a secure job, you can give GATE, and you can but you have to rank within 50 in GATE to go into IOCL, ONGC or NTPC. Like as a chemist officer, you will a grade A officer you will become. So these are the options you can pursue after your MSc. So for pursuing PhD from India, what are the things you have to do? Like you have to qualify the CSIR NET exam, which is conducted twice a year, like in July or June and one in December. And you have to qualify GATE with a good rank. And one thing I like to say that if you have done your MSc from any IIT, like any of the 23 IITs, and if you have a like good CPI, above 8 or above, you will be shortlisted for the interview in any IIT. Without CSIR NET, without GATE, nothing is required. Because you have done your MSc from IIT. Only because of this. One of my friend, she completed a master's with me. She did not have a CSIR NET, and she had a very bad rank in GATE also, but she's pursuing her PhD in IIT Delhi today. So these are the parts of studying in IIT, I would like to say. So all these three will help you to get shortlisted for an interview only. The final decisions will be made based on that interview. Like the professors will sit a panel, inorganic, organic, physical. You will give your preference. No, I am more interested in inorganic, or what's your organic? And that professor will ask you questions. So everything is based on that interview. And if you qualify with GATE also with AIR1, you have to give an interview. So for pursuing PhD from USA, I know more about this rather than knowing what because I myself is going. So you have to give English proficiency exam, which is the TOEFL exam. It's out of 20 marks, 120 marks, and there are like reading passages, listening things, like you have to listen with over the headphone, and you have to answer some questions like this. And there are speaking skills also tested, like they give a topic, like you have to speak on that topic, and for 60 seconds, there are like four parts, like one for 45 seconds, one for 60 seconds. You have to like sit in front of the computer and you have to speak. And if you fumble, it's gone. And writing passages also, there are 2 writing passages where they give at the last, and you have to do that. So it's a exam out of 120, but 100 or a above 100 score is like plenty, like very competitive to apply to the highest rank university. Like one of my friends with 98 score also is going to US. So that does not matter a lot. But yes, if you have a score above 100, it's good. Like I had myself had 104 score in my TOEFL. And GRE exam is mostly waived in for chemistry in many of the US universities after COVID, because GRE exam is a little like a different, like it involves maths. 10 level maths, and the English is very, very tough, like nothing beside compared to TOEFL. I also gave GRE, but I could not submit any of my GRE scores to any of my universities, because they, in the portal, we do not need GRE scores for considering your application. GRE is out of 340. I scored 315, but I could not give my scores. Okay, so a good research background is very, very important, because if you do not have a good research background, on what basis will they take? Like I want to do my PhD in chemistry in organic. If I show that I have done my MSc in inorganic, like that's not feasible. Yes, you can change your stream, but it's a negative impact, like false. I did my master's in synthetic organic chemistry, and I am going to do PhD in synthetic organic chemistry. So a little like asymmetric organocatalysis and this, but a research background is very, very, very important, very important. And I would like to say that if you go into IIT, they give only the last semester for your MSc thesis, like only a 6 months, not fully 6 months, it's 5 months only. But I did my MSc project for 1 year. How did I do that? Like from May 2022, I approached my professor, like Subhash Chandra Pant, doctor, and I told him like I want to go to US and I want to do my research very extensively for 1 year, because as you know that for only for 5.5 months 80 compounds, that would not have been possible, at least for me. Okay, so having a research background is very important, and why I'm telling that 1 year or 8 months or 9 months are good, because first when you are going to a synthetic organic chemistry lab, you have to know the apparatus. For knowing the apparatus and setting up the reactions, like dry reactions when we have to set up in argon atmosphere or in nitrogen atmosphere, it's very difficult. It's not like I'm taking 2 reagents, mixing and putting on a magnetic stirrer. It's not like that. You have to like parch the reaction, and there are various steps. So it only takes 1.5 to 2 months for learning these things. If 2 months is gone in learning these things, only 3 months left for my MSc thesis. That's not possible. So it's better to do your, like I approach him like professor said, like no, IIT gives only the last semester for your MSc. So how can I take, like on what basis I will say, Lord, I am taking this student. So I told that I am going to do the summer internship also under you. So that summer internship plus my MSc thesis, it from May 2021 to April from May 2022 to April 2023. Okay, and as I said, that CPI is a key factor, very, very important thing. Like you have to study in IIT. If you get into IIT, you have to study. Like IIT campuses are very nice. I myself studied in the most beautiful campus of IIT Guwahati. But you can roam, you can do whatever you like, you can join many clubs. There are various options, but you have to study at the end of the day. And IITs are like, they take surprise tests every day. Like 8 a.m., I went into my binary class and said is giving sheets. What happened? No, I am taking an surprise test. On what topic? The thing that I taught yesterday. Like you have to be very punctual, and our classes used to start at 8 a.m. and if you go by 8:05, you are done. You have to stay outside, no enter to the class. Like if one says that no, I was having my breakfast, go and have your breakfast. They are very cool and very everything, but they are very, very strict about like they will teach with all of their efforts, with all their everything, but you have to give it back. Like they told me that In first semester, my CPI was 9.22, and they said, no, below 9.5, this is a CPI, like this, and from the next semester, I increased it from 9.5, then 9.8, and the last semester I got a 10 CPI. Okay, so in average, they average the 4 CPIs, and my CPI is 9.6 after 2 years of MSc Chemistry. And the 3 letters of recommendation for US, it's very, very important. These recommendation letters mean a lot. But you have to take one from your research advisor, because your research advisor knows you the best. He knows you in lab. My professor knew me in lab. It's like, am I maintaining a lab notebook? Am I diligent enough to do the reactions? Am I punctual to go in the lab in a particular time? And the 2 other letter of recommendations you can take from your course instructor. But I would like to say that there are that no marks is given in IIT. Like, you will never know your marks in IIT. Like, there is relative grading, and they grade you. Like, AA is the highest grade, then AB, then BB, like this. So I would like to say that if you want to take your 2 letters of recommendation from your course instructors, like I took from my 2 organic course instructors, take it from that professor under whom you scored AA, because he or she have to write that score, that this student scored AA in my course, because they don't know anything about beyond that. Your research advisor knows you how you perform in lab and everything, but your course instructor only knows you by your grade and nothing else. And statement of purpose. This is very important, because statement of purpose is the most pleasing and enthusiastic thing. Like in the US universities, they tell you, like, what motivated you for PhD? What motivated you for pursuing for pursuing chemistry as your career? And why are you coming to this university? Like, all these things have to be told in a statement of purpose. It takes about like 2 pages. They allow 2 pages, and you can use any font or anything. It should be very competitive. Like, why I love chemistry. This thing is very, very important, and why I am choosing your university over the others. Like, I got 4 acceptances from Rochester, from Texas A&M, from Florida, and from Indiana University. But I am not going to these 3 universities. But in the SOP, I had to write, no, I will be going to your university to please them. I am rejecting these 3, and I am going to University of Florida. But while writing my SOP, you have to tell, no, your university is very, very good, your lab is very, very good, your lab is pleasant, and you have to give 2 to 3 names of the professors that under whom you want to pursue your PhD. Like, I will say, like in USA, the admission process is like, you have to first, the admission committee, the general admission committee sees your application, and if they find it competitive, they send it to the professors, like the 3 professors or the 2 professors name who you have mentioned. And if they find that, no, I have vacancy and this student is competitive enough, they will send you acceptance letter. But in Germany, you have to directly mail your professors with your research proposal, and not through any admission portal. I will tell that later. And a curriculum vitae CV, a strong CV is always competitive, as you all know. So these are the things, these are the nominal things that you have to do to pursue your PhD from USA. And the most important thing, I would say that it's your research and your CPI. Your CPI matters a lot. If you have a good CPI, your professor is bound to give you a good recommendation. He can't, if I am scoring 9.5 CPI, he can't tell that, no, she's a bad student. That's not possible. That's contradictory. That's not possible. Oh, so for pursuing PhD from Europe. So as I told that for pursuing PhD from Europe, you have to directly mail the professor. Like, you have to shortlist your professors and you have to directly mail them. Not like this USA, like you fill the application form and in the SOP you write your professor's name under whom you want to do your PhD. So research background is very important, because you have to send your research proposal to that professor. If your research proposal is good and it aligns with your professor, your research interest of your professor, then he or she may schedule an interview for you, and he or she may take you. and 2 to 3 letters of recommendation like USA only. It varies from universities to universities in Europe. And in some cases, TOEFL is required, but I don't think like TOEFL is very, very important for you. Like if you're going to Germany, what is the use of English? German, they speak German. So, but you don't have to study German for that, no. One of my friends is going to Scotland, so nothing. So one of my friend is going to Germany, so nothing is required. But one of my friends faced this problem. I wanted to share that she did her MSc thesis in green sustainability reactions, but she is applying for the topic that I am going to pursue, like organic catalysis, asymmetric catalysis, but she's not getting into any universities in Germany. Why? Because her MSc thesis is not showing that experience. And one thing I would like to share that in USA, the PhD course is for 5 years. Like I am going August, for 2 to 2.5 months, I will just do lab rotations and select my like research guide or my PhD guide. Like they give us an option to select my advisor. But in Germany or in Europe, the PhD is for 3 years. Like in the 3 years, you have to complete your PhD. Like after taking you, they put you in a lab. They don't teach, from the very first day you are researching. So having a very good research background is very, very important for Germany, for Europe, I would say. And the curriculum vitae is necessary for everything. So according to me, the PhD is not about universities. You may go to a very high QS world ranking university, but your PhD guide is bad. That's not done, because your 5 years is dependent on that professor only. If your PhD guide is not cooperative, he or she is not helping you, he or she is not taking you out of the situations in which you are stuck, it's of no use, nothing. Because selecting a PhD guide is very, very important, and rather than selecting your university. Like University of Rochester has a better QS world ranking than University of Florida, but I didn't go there because I had a better PhD guide in my University of Florida. So after PhD, it's a 5 years course, and it's very, like people say it's very frustrating. Many people said that, why are you going to do a PhD, like do some corporate jobs? No, I love it. I am going to take this as a challenge, I would like to say. So after PhD, you can do your postdoc if you want to stay in academics, or you can do any industry jobs in the foreign countries if you want to go abroad, or you can come back after doing one PhD and then one postdoc to India and become any assistant professors in any of the IITs, ISC Bangalore. You have many options. So science is something that has changed our lives to many folds, and I have loved chemistry for a very long time. Chemistry has been my passion, and it has rewarded me in a lot of ways I never have dreamed of. I never dreamed that I will be getting a gold medal from Jadavpur University. I never dreamed I will be getting you, because when I was pursuing my bachelor's, people only say that BTech, MTech from IIT. What is MSc from IIT? But I got into MSc from IIT, and I am very glad that I opted for IIT JAM. It's a tough exam, I would say, but if you have love for chemistry, you can do anything. And I would like to say that hard work always pays off, always. Like if you love a subject, let it be any subject, biology, chemistry, English, maths, physics, any subject. If you love it and you give your 100%, everything, your days, nights, everything. And one thing in IIT is that, I would like to say that one exam after the other. One exam Monday, one exam Tuesday, one exam Wednesday. And day came in my life where I gave an exam in the morning, 8 a.m., and I gave an exam in 5 p.m. One is organic, one is inorganic. So these things happen in IIT. Like IIT is not so easy. So like they teach their course up to Saturday, exam is from Monday. Like this, no study leave, nothing is there, nothing. Like I gave my second semester, like waking up for 72 hours. like 72 hours, because the syllabus was so huge. I couldn't complete. I used to started organic, gave the exam, came back, started biochemistry, gave the exam. Like it went for 72 hours. So it's very hectic for studying in IIT. Very, very hectic. So this was my presentation. So I hope you liked it. And if you have any question, you may ask. And thank you. And I'm very grateful to the Future Foundation School and the teachers of the Future Foundation School for giving me this opportunity, and the foundation that has shaped my journey. Because without them, I wouldn't be standing here. I am very, very grateful to them. Thank you so much. If you have any questions, you may ask. Any questions?
Ma'am, if one if one has to do from physics, from IIT and all, after
same.
Can one go for research?
Yes, same. The IIT JAM is for economics, physics,
No, after
maths.
giving JEE Main and advance.
You have to go into ISER then, or ISC Bangalore. ISER is for BSMS course, 4 years, and then you can go for research. And in ISC Bangalore, it's a 4 years BS course only, then you can go for PhD. Anything.
So IIT is not an option then, if one has to go for research after JEE Main and advanced?
No, after JEE and advanced, IIT is not taking students for BSc. There is no course for BSc in chemistry.
There is no course, but after doing that course from IIT, can one do research?
What course?
From say computer science?
Yes, anything. BTech students are also going with me.
Oh.
In USA, there is no criteria that you have to complete your masters. Like in Yale University, I have done masters, but if I go into Yale University, they will I have to do again 2 years masters. In spite of I been completing my MSc. Like MSc is not a criteria for pursuing PhD in USA or any other foreign country, I think. But I am more confident about USA because myself is going. But you have to research for Europe yourself. I don't know, I don't know much about Europe regarding this bachelor's and master's.
Okay, so is a personal profile or SOP relative for various universities? So in some universities, SOP is accepted, and in some universities, it is not accepted. For example, for a PhD in Europe, there was no mention of SOPs.
No. Some universities, they take SOP in Europe, and most of the universities, they don't take, because the main is the research proposal. You have to mail your professor directly. In USC, you are applying through a portal. There are various things like give your CV, give your transcripts, like your grades. But in Europe, you have to directly mail your professor with your CV and your research proposal. Research proposal is the most important thing for Europe. And for USA, resume document, as I told, CPI is very, very important. And SOP has to be very pleasant and very insightful, I think.
Okay.
If somebody doesn't have biology as a subject in their +2 level, will that be a problem?
No. They don't see that ICC, ISC courses. They only see the BSc and MSc.
All this while you mentioned about all the top universities, but because you were one of those top students, but what if on a serious note, IITs give, as far as I know, I am interested in computer science and stuff, so IITs give the good subjects and to the top rank holders. So what about the mediocre students who are,
like as I told, that NITs take students, like I know about chemistry only and not your computer science, they take general students up to 950 rank. Okay, and as I told that ISERs, they take a different admission test. JNCSR don't take different admission tests, they shortlist on the basis of the JAM rank. And TIFR Mumbai, TIFR Hyderabad, one of my friend, as I told, is person Shulagna, is pursuing PhD in integrated MSc PhD in. So you have to give your best, or else how will you get?
Yes, ma'am, I know that all our life we have to give our best. But what if, we always need a backup, right? What if things go wrong?
For IT JAM?
For anything, for
you have
JEE mains, for anything.
So you have to give your I know I did honors, so you have to give your best in ISC, because 95% is nothing now. everyone is getting 95%, everyone. So if you have a good score in your science subjects, like in physics, maths, chemistry, like in Jadavpur University, they take the 3 of this, and in which subject you are pursuing your honors, like in chemistry, they do it in 2 into chemistry, plus physics, plus maths by 3. And if it's above, like, I don't know, but my name was first in Jadavpur University. So, because it was 100 in chemistry, so 2 into 100, it didn't get less. So, you have to do best in certain time of your life to achieve this height, I think. Like, you can't, like, be a, like, average student is good. Many of my friends who have scored, like, CGPA 8.2, 8.3, they are also going to US. That's not a problem. But for achieving the heights, for getting the best advisors, like in your PhD or in any stream of your life, you have to give your best, because not giving your best, you can't dream of them. Like, I can dream of US because I have a 9.6 CGPA.
Okay, so as she said that, what about the mediocre students? See, honestly speaking, I personally never liked physics, loved chemistry. Fitji killed my interest. Thank you, Fitji. I am in the PCM subjects. The only subject that I love is maths. And I am very interested in computer sciences. But the Indian education system does not permit me to pursue computer science as a subject until and unless I give an entrance exam based on PCM. So, like, would you recommend that I go out for just the bachelor's only, I leave India and do it?
Yes, you can do that. You can do that. Like, for bachelor's, you have to, it's not funded, first thing. Like, my PhD is fully funded. It's fully funded. Like, my father is only giving the flight fees and nothing. It's fully funded. But in bachelor's and masters, it's a like hefty amount of money. It's not funded, first thing is that. And for PhD, the scope of getting into USA is more. Okay, because you have a good research background, you have everything.
No,
and
but like
you can go.
No, what I'm saying is, would you recommend going abroad for the bachelor's over staying here in India? So just for the bachelor's.
One thing, if you do BTech from IIT, then India is a better option, I would say.
Achha,
From
but,
IIT. Or NIT, I would say. NIT is also
and,
good.
could you recommend something in Europe?
Like in Europe, I don't, as I said that I'm not going to Europe, so I don't. But you can go to their websites. Like, one of the key factor and the most important factor for Europe applications, like, they are open 365 days a year. But in USA, they only open in the August and they close in December. So you can go to their websites, you can see. But one thing is, the visas are also a big problem. Like if you are funded, they give your visa like instantly. I got my visa in 1 day only. But if you are not funded, you have to show your bank accounts, you have to show your father's income, mother's income, everything. And like, there are chances of rejection for visa. But if you are going to a fully funded program, they can't reject you, because the US universities or the European universities are funding you or taking you. Your father or your mother don't have to give anything. So visa is also a problem. You should, like, you are giving a lot of money, but at the last moment your visa gets rejected. That's not a good thing. Like.
Thank you.
Acha, Soumili, one question. With chemistry or with biology, what is the prospect of sustainability? Environment sustainability, renewable energies, what is its prospect of this?
It's prosperous. Like, one of my friend is did her MSc thesis on environmental sustainability, and she's going to Europe. Germany. She's going to Germany. Like, the research background matters a lot. Like, whatever field of chemistry or biology we are researching in. Like, you have a good research background. Like, for 1 year, I did so many studies, so I have so many data and all. The research background matters a lot. Like, we have to mail the professors with that research proposal. Like, every professor gets 100 to 200 research proposals every day. So why will your research proposal will be the strong out of all this? So the research background matters. Every USA, Europe have a scope in everything. Like one of my friend in humanities is going to USA, humanities, and we are science students. So in sustainability only, so ma'am, anyone can go, because my friend is going.
And for this admission in US and Europe, is there any particular 2-3 site where all of these are there?
No,
Or you have to go individual
No,
site?
individual sites, like you have to search University of Florida, you have to search Rochester University application. Then in the August, like in my time, in the second week of August, they opened the application portals, and by 1st of December, the application portals are closed. And by January, like I got my first acceptance on Saraswati Puja, 26th January. So by January, February, we get our acceptances.
And how do you get this ranking, like which universities you choose? How do you choose the university?
I chose my university based on chemistry ranking. Like I chose University of Florida chemistry ranking. So by subject wise, you have that QS World ranking by subject wise also. So since I am going to do PhD in a particular subject, so I search for that QS World ranking by subject, and then I selected the professor. Like shortlisting the professors is a very important task.
Professor profile is also
Yes,
there.
yes. In the university portal only, like Department of Chemistry, every professor mail ID, their research, their publications, everything is given. You can see that from the publications. Like if a professor has 2 to 3 publications in 2023, then he is obviously good. And you can search for the H index also, like Google Scholar H index. Like the more number of publications, the more citations a professor has, the higher is the H index. Like our H index above 20, it's very good. And if it's above 50, then he or she is an excellent professor. And you can contact the US professors before filling your applications also. Like I contacted 2 professors from University of Pennsylvania, and they told me that please don't apply. We don't have any vacancy. So please don't waste your money in applying, because in applying to a particular university, it takes like 5K to 7K. So don't waste your money before knowing that this professor has a vacancy. So it's always feasible, like you give your TOEFL, like I gave my TOEFL on 27th August, and within 4 to 5 days you get your result. So after getting your result, like then and you have to start shortlisting from the very beginning only. If I have shortlisted professors, then start mailing them with your CV. Like I am interested, can I apply? Will you be taking students in fall? Like I am going for fall 2023. In August, fall semester starts, and in January or February, spring semester starts. But in fall, the intake of students are higher compared to spring. So mail the professors, I would say, mail the professors before applying. Like if they don't have vacancy, then you are wasting your money applying to, because you will get a rejection only.
Ma'am, you are proceeding on to your PhD, right?
Mm-hmm.
Ma'am, how did you choose your research topic, or what they assigned to you?
No. You can choose your professor. Like from bachelor's only, I was more interested in organic chemistry. So in MSc, in the first 3 semesters, there are normal topics like thermodynamics, like physical chemistry, inorganic chemistry. But in the when the second year starts, you have to choose your professor. But you can go to various labs, and you can do some work, like see the work of your seniors, like if you are interested in it or you are not. And one more important thing is you have common practical, like as you do practicals in your school, there are common practical sessions in the first semester, second semester, third semester, physical, organic, inorganic. So by then you will know your interest. Okay.
Thank you, ma'am.
Ma'am, how important are the university rankings when I'm choosing something? Like if I compare Massachusetts Institute of Technology and
that's obviously
Malvern
better.
Institute of Technology, there will be a big difference. But if I
Yes.
compare MIT and Stanford, there won't be much of a difference. So how important are these rankings?
So if you are going for MS in chemistry, your university rank matters. But if you are going for PhD, see the research profiles of your professors. Like if you are going for inorganic chemistry, or I say that organocatalysis, if you have a better professor in Stanford compared to MIT, go for Stanford. Because your 5 years PhD is dependent on that professor only, not your university. Because your research publications will be like published under your professor, not like, yes, there will be written you are doing your PhD from Stanford. But if your professor is not cooperative, not good, then going to MIT would not be like a good option.
Ma'am, after giving the Olympiad examinations, like are people
Okay.
selected into universities?
You have to mail them. Like one of my friends, like I said that he did his BS physics course from IISc Bangalore. He was a gold medalist Olympiad student. Okay, but he did his BS and then he went to Ohio State University. Look, like you have to mail them, like what are the options? Like if you don't talk to them directly, if they don't know you, then you can't do anything. You have to mail them. Like I am an Olympiad gold medalist. Can I apply? Then what are the procedures that by which I can apply? And the US professors are very they reply like some in the IITs the teachers don't, professors don't reply. Like in my IIT only, if I mail one of my professors, they will reply after 2 to 3 days. But in US they reply, like the time zone is different, but they reply, like they are very humble. Like I would like to share an incident. Like I was very confused between University of Rochester and University of Florida. So I wanted to, before accepting their offer, I wanted to do some meetings with the professors that I have selected. So Rose Kennedy was a professor in University of Rochester, and she sent me her calendar, like you select time, and at that time we will meet. So I didn't know that calendar was in IST time. I thought that it's in New York time, so I selected 12:30 a.m. thinking that it's I don't know 6:30 p.m. in India, but it was 12:30 a.m. in India. It's a calendar in IST. So and then I was in IIT Guwahati. So 12:30 a.m. I was sleeping. So next day I woke up at 7 a.m. and I found a mail that ma'am has mailed me that I've been waiting for you. I think it's a late night in India. So please schedule another time. If it's a professor at IIT, they would tell you bad things. But they're very humble, very humble, very humble.
So there is no direct selection into universities after Olympiads and all.
So
Like
that I
MIT
don't.
or-
But you have to give some exam, I think. Like one of my telling students, one of my batchmates, he was rank 2 in West Bengal board in my time in 2021, and he gave SAT, and he got into University of Sheffield, UK, and now he's going to Oxford for PhD. So you have to mail them. You have to know the exams that you have to give. You can mail them. They are very good. They are very informative and everything.
So let us end the session. So it had been a great pleasure, and I must say it had been a great opportunity that we have attended your program. So it was really very enriching and inspiring too for all of us. And on behalf of the entire Future Foundation School, the family, I extend my gratitude. And I thank you. And we are expecting more such sessions in the future, but she will be moving to USA soon. We have already heard about that. So if you can manage to come again in the future, we are really very grateful to you.
Thank you so much.
First class 11, you will have to disperse in silence. First class 11 students.
And I will share my email ID. You can contact me anytime. I will share my email ID with Shongita ma'am, and she can give it to you all. And you can ask me any questions whenever you like. But the time zones will be a little bit difficult, but I will get back to you whenever possible. Thank you so much.
And Shoumi, please don't lose your hopes. There are many opportunities for the average students as well. You can get admitted to different colleges in India only. So leaving India is not a solution always. Please be here and stay with us. That is more important.